In Java, both break and continues are keywords. They're there to control your flow of executions, meaning it could be altered inside a for, while, or do while loop, depending on where you place either break or continue keywords. You might have seen this a few times. The break statement is used to terminate the loop immediately. So, for example, if you have a for loop and a break in it, it'll exit that for loop immediately when the break is evaluated. Same thing applies to the nested for loop, where you have a for inside another for. If your break statement is inside the inner for, that break will break out of the inner for, but you'll still be inside the outer for loop. If you wish to break out of a nested for loop in this fashion, you'll need to have another break that is associated with the outer loop, so that effectively when you're exiting out of the inner loop, your flow of control will land on the next break, taking you out of the outer loop as well. So that's break statement. Continue statement is the exact opposite of your break. Instead of terminating the loop, it basically skips the current iteration and continue with the loop. Notice that continuation means the next iteration. So if you have a continue at line 19 and there's more statement at 20 and 21, whatever they are, continue means continue with the next iteration, forgetting about what you have after line 19. This is an important distinction between a continuous statement versus the other statement, where non-continuous statement will be evaluated one at a time. Continuous statement only evaluates once, taking the flow of execution to bypass all of the remaining statement with the goal of taking you into the next iteration. Just like for break, if you have a nested for loop and your continue is sitting inside of inner loop, this continuing to the next iteration only applies to the inner loop iteration and not the outer loop iteration. Let's look at two examples, one each for break and continue next. This is a sample snippet that showcases one for loop where initialization happens on I equals 0. As long as I is less than 10, let's iterate them one at a time. But you would break out of this iteration when I equals 5. Otherwise, continue to print system out print line and the number itself. Let's do this together. Very first time I is 0. And since I equals 5 is false for I equals 0, you will simply print 0 to the console. Since we have system out print line, this introduces invisible line break on the console. Now I++ means I is now 1 and 1 is less than 10. Again, you're going to bypass this entire break to print system out print line I, which will give you 1. Next up, I will be plus again. I equals 2. 2 is still less than 10. You're going to bypass this break because I equals 5 is false. System out print line, you get 2. Fast tracking, we all have 3 and 4 until I++ becomes 5. 5 is less than 10. It'll continue the loop. If I equals 5, now I is 5, it'll hit the break. This break takes you out of the iteration completely. And the iteration we're talking about is this for loop right here, not this if. This if is only a conditional. So this break breaks out of the entire for loop, taking you directly into this very next line after the for loop, which is end. It will have system out print line at the end with a comma. This is what this break snippet is going to print to the console. You should try this to verify what we just did. Let's look at some snippet for a continue example. This is a single for loop. I equals 0, I less than 10, I++. Notice that we have I mod 2. This percentage sign is the modulus operator. And remember, the modulus operator is equivalent to getting you the remainder of a division. For example, if we have 1 mod 2, this will yield 1. In grade school math, this is how we represent it. 1 divided by 2 with a 0 quotient. 0 times 2 is 0, and your remainder is 1. This is your remainder. On the other hand, if you have 2 mod 2, this will give you 0. 3 mod 2 will give you 1. 4 mod 2 will give you 0. You can see the pattern. And the pattern is, as long as you have an even number in a numerator, your modulus is always going to be 0. So saying I mod 2 equals 0 basically means that I is an even number. If I is an even number, this is going to evaluate to true or continue the iterations. In other words, skips the rest of the loop body for even numbers. However, if I is not an even number, this is not going to be true. That non-even number will system out print line to the console. Let's evaluate this together. When I equals 0, I mod 2 is going to be 0. So we'll hit continue. And there's no system out print line with continue. Because now it will be in the next iteration, which is I equals 1. And I equals 1 is still less than 10. But 1 mod 2 is going to give you 1. So this is going to be false. And system out print line is going to take effect. So the very first odd number that will be printed to the screen is 1. And then we get into I++ equals 2. 2 is less than 10. And 2 is an even number. So 2 mod 2 equals 0 is going to hit continue with nothing else to evaluate. And it goes into I equals 3. 3 is less than 10. And 3 is an odd number. So this is going to be bypassed, printing out system out print line 3. So you have 3 here. Let's keep on going. 5, 7, until you get to 9. Let's look at what happens next. I++ when I equals 9 is going to give you 10. So 10 less than 10 is going to yield false, which means the entire for loop is done. There's no break or anything else. The entire for loop simply terminates due to this conditional. And there's nothing else to print after that. Therefore, what you see on the console is 13579 using the continue statement. This completes our illustrations of both continue and break examples inside loops.